Hi guys! Today we're going to look at how we can create a simple day-night cycle in Unity. We'll cover how to display the current time, how to change the direction of the sun as the day progresses, and how to transition to moonlight at night. We're going to demonstrate this with a scene we created in our 3D platformer series, but it will work with any 3D scene. Okay, we'll start by clicking the plus button on the hierarchy and adding an empty game object. We'll name this time controller. We'll add a script to this object that will contain all the logic for managing the day-night cycle. To do this, we'll click the Add Component button in the inspector and add a new script. We'll name this time controller as well. Then we'll double-click the script to open it in the editor. The first thing we'll do is add some fields to control the cycle. We'll add a private float field called Time Multiplier. This will control how fast time passes in the game. We'll make this serializable so that it can be set from the inspector. Then we'll add another serializable float field for the hour we want the game to start at. We want to be able to display the current time, so we'll add another serializable field for a text UI object. We'll need to add the TM Pro namespace for this. The time is going to progress each frame, so we need a field to keep track of the current time. For this, we'll use a date time field. We'll need to add the system namespace for this. This type can hold date and time information. We're not going to do anything with the date component, but using this type makes the calculations easier. In the start method, we'll set the current time to today's date using datetime now. We'll just take the date component and then we'll add the desired start time to this date. To do this, we'll use the time span from hours method. Next, we want to increase the current time each frame. We'll create a method called update time of day. In here, we'll add to the current time using the add seconds method. Time.delta time will give the amount of actual seconds that have passed. We'll then multiply this by the time multiplier to have the time change at the desired rate. Now we have the time updating, we'll optionally display the current time on the UI. We'll check that the text field isn't null. If it isn't, we'll set the text to the current time. We'll use the toString method and pass in the format HH:MM. This will display the time in 24-hour format. Then we'll call this new method from the update method. Let's save this script and switch back to Unity. We'll add a text UI object to display the time. To do this, we'll click the plus button in the hierarchy and then select UI Text Mesh Pro. When prompted, we'll import the Text Mesh Pro Essentials. We'll name this Time Text. Then we'll make some changes to the position and formatting of the text. We'll click on the anchor button. We'll hold down Shift and Alt and then click on the top right button. This will anchor the text to the top right of the screen. We'll also make the font bold. We'll increase the font size to 50. And we'll select Center Alignment. Then we'll select the time controller in the hierarchy and drag the new text object into the time text field in the inspector. We'll set the time multiplier value to 2000 to have the day pass quickly. And we'll set the start hour to 12 to have the game start at midday. Let's press play to see what happens. Now we can see that the time starts at midday and then increases. It will get all the way to 23:59 and will then start at 0 again. Now we have the time of day sorted, we need to change the lighting accordingly. Let's stop the game and have a look at what we need to do. In the real world, the position of the sun in the sky and the direction of sunlight changes during the course of a day. We have a directional light in our scene that we're using to simulate the sun. To mimic the changing position of the sun, we're going to rotate this light as time passes. For example, let's set the rotation of the light to 90 degrees on the x-axis. We can see that the light is pointing straight down. The scene appears bright and the shadows are directly below the objects. This is what we want the scene to look like around midday. Let's change this to 10 degrees. Now the scene is much darker and the shadows are longer. This is what we want the scene to look like first thing in the morning or last thing in the evening. Then we'll change it to 270 degrees. Now the light is pointing directly up. The scene is darker and there are no shadows. This is what the scene will be like in the middle of the night. Let's switch back to the script to change the direction of the light automatically as the day progresses. First of all, we'll add a new serializable field for the light representing the sun. We want the sun to rise and set at specific times, so we'll create float fields for the sunrise hour and the sunset hour. From these serializable fields that we'll set in the inspector, we're going to convert to time span values to aid our calculations. So we'll also create private time span fields for the sunrise time and the sunset time. In the start method, we'll then create the sunrise and sunset times using the time span from hours method. Now we need to work out the rotation of the sun based on the time of day. To help with this, we'll create a method called calculate time difference. This will take a from time and a to time as parameters and return the difference between the two times. To calculate the difference between the times, we'll subtract one from the other. Then we need to check if the difference is negative. If it is, it means the two times span the transition from one day to another. In this scenario, we need to add 24 hours to the difference to get the correct value. Then we'll return the calculated difference. Now that we have a method to calculate the difference between times, we can use it to determine how long it is until sunset or sunrise, and then set the sun accordingly. We'll create a method called rotate sun. In here, we'll create a variable to hold the rotation of the sun. Then we'll check if we're in daytime by checking if the current time of day is between sunrise and sunset. If it is, we'll calculate the total time between sunrise and sunset. Then we'll calculate how much time has passed since sunrise. We can then use these two values to work out what percentage of the daytime has passed. To do this, we'll divide the amount of minutes since sunrise by the total amount of minutes from sunrise to sunset. We'll then use this percentage to work out the rotation. We'll lerp between 0 and 180 and use the percentage as the interpolation value. We need to cast this to a float for this to work. So what this will do is set the rotation value to 0 at sunrise. This will then increase as the day progresses before reaching 180 at sunset. If you're not familiar with lerp, then take a look at our dedicated video on this. Next, we'll add an else statement to handle the night time. We'll calculate the time between sunset and sunrise. Then we'll calculate the time since sunset. We'll use these values to calculate the percentage of the night that has passed. This time, when we calculate the rotation, we'll lerp between 180 and 360. Now that we've calculated the rotation, we can apply it to the sunlight. We'll do this using the quaternion angle axis method. We'll pass in vector 3 right for the axis to have it rotate around the x-axis. We'll then go to the update method and call the rotate sun method from here. Let's save the script and switch back to Unity. We'll select the time controller in the hierarchy. Then we'll set the sunrise hour to 7 and we'll set the sunset hour to 20.5. So we're saying we want the sun to rise at 7 in the morning and set at 8:30 in the evening. We also need to drag the directional light into the sunlight field. Let's press play to try this out. We can now see the shadows getting longer as the direction of the sun changes. Because we're using the default skybox, we can even see the sun moving in the sky. It does get darker at night, but doesn't look quite right. The leaves of the trees are glowing and there is too much ambient light. We also don't have any moonlight yet. We'll stop the game and go back to the script to fix this. Ambient lighting is light that doesn't come from any particular light, but does contribute to the overall brightness of the scene. We want to have a brighter ambient light at daytime than we do at nighttime. We'll create 2 fields to hold a colour for each. We then want to transition between the two smoothly. To help control this transition, we'll add an animation curve field. The glowing leaves are actually caused by the sunlight, even though it should be being blocked by the terrain. To fix this, we're going to turn down the intensity of the light at nighttime. We'll add a field for the maximum sun intensity so that we can set it back to this at daytime. To make the nighttime a bit more realistic, we're also going to add in some moonlight. This will be another directional light that will be less bright than the sun. We'll add a field for this light. And we'll add a field for the maximum intensity of the moon. Now we have all the fields, we'll create a new method called Update Light Settings. First of all, we'll adjust the intensity of the sun. At midday, when the sun is pointing directly down, we want the intensity to be at the maximum. Then at night, we want it to be all the way down to 0. To do this, we're going to calculate the dot product of the forward direction of the sun and the down direction. What this does is give a value between -1 and 1, depending on how similar the two vector directions are. So if the sun is pointing directly down, then we'll get 1. If it's pointing horizontally, we'll get 0. And if it's pointing up, we'll get -1. We can then use this value to change between daytime and nighttime settings. We'll use lerp again to set the intensity of the sun between 0 and the maximum. We'll use the calculated dot product as the interpolation value. To give us additional control, we'll feed this into the animation curve first. This will allow us to create a non-linear transition. Then we'll do the same for the moonlight. This time we'll lerp the opposite way round, so we'll go from the maximum to 0. This way the moon will transition on as the sun transitions off. We'll then set the ambient light. We'll use colour lerp to transition from the nighttime ambient light to the daytime. We then need to call this new method from the update method. Let's save the script and switch back to Unity. Let's add a new light for the moon. To do this, we'll click the plus button in the hierarchy and then select Light, Directional Light. We'll name this Moonlight. We'll change the colour of the light to a light blue. Then we'll select the time controller object in the hierarchy and drag the new light into the Moonlight field. We'll set the maximum moonlight intensity to 0.5. We'll set the maximum sunlight intensity to 1. For the daytime ambient light, we'll select quite a bright colour. For the nighttime ambient light, we'll select a dark blue colour. Then we'll click on the light change curve. We're going to change this to a curve so that we get a much faster transition between day and night settings. We'll right-click on the curve and add another key. We'll right-click on the new key and select both tangents weighted. Now we can position this to get a smooth curve with a steep initial incline. This means that, for example, the sunlight intensity will be 0 at sunrise, before quickly getting to the maximum and staying at the maximum for most of the day. Let's press play to try this out. Now we have a nice transition from day to night. Then we'll transition back to day again. One note of caution with this. If you're using any baked lighting, then it won't work well with this day-night cycle. If you bake lighting with bright daytime lights, then it obviously won't look right at night. Okay, that covers everything for this video. Hope you found it useful. Please leave any questions or feedback in the comments, and subscribe and click the bell icon so you don't miss the next one. If you find our channel useful and would like to help support our work, you can find us on Patreon and Ko-fi.com. Thanks guys!